Good morning, good morning. We're doing some recording because I teach online too, in air conditioning, a lot of theory class. And here is my two assistants, one who's recording, this is Michael, he's in my class, and Hernan too, he's in my class also. He's gonna help out here with a couple of electricity experiments, so you can see how this works a little bit. And I'd like to say hi to the online classes and everyone else. We're in a cosmetology class. They have to learn chemistry and electricity because you guys are working next to some high voltage. You're working with people. You have to know your chemicals. And if you're going to be licensed, have your own business, you have to know what you're doing, right? Like each and one of us has to become involved. If you have that passion, you're going to get to know a whole lot about your field that you're into right now. I'm sure your professor discussed the Ohm's law, which is, here's the formula. I don't know, did you go over this but I won't get too much into that.
Not so much in detail on that.
Okay.
The terminologies and how it relates to our.
Okay, this is what.
Oh, taking my picture.
I got here a couple of important, I could say, this is what's called a solenoid. But why did I bring this motor in here? What does that have to do with you? Well, the motors you have in your hair dryers is basically, it runs by the same principle as this one. It's got a part that rotates and a part that stands still. And you can see this part in here, there's wiring, there's copper wiring, and it develops an electromagnetic field. Okay, when you have electricity, you're working around electromagnetic field. Now, I'm going to demonstrate what that electromagnetic field is when you have some power attached to it. So what I'm going to do is, I'm going to hold this here, and we're going to turn this on. Obviously, I'm not going to get electrocuted because we have, this is direct current. He's going to put the screwdriver through here. Okay, he's going to let it go. And you see how it's holding it. Because the electromagnetic field that's around is copper wire. Now, if you were to twist this around, he shut it off. That's fine, but that's what's going to happen. Now, let's do it again. Turn it on. He's got it on. Now twist it around. Turn that around. That same principle is what turns around that part that I just pulled out, and even on your blow dryer. Power 120 is added to this part here and makes this part turn. And this is what is in your blow dryers, motors like this. Okay, thank you. Now, if I were to ask you, what is the difference between direct current, DC, and alternating current? Basically, on your battery, you see a battery, excuse me?
I think AC goes in both ways and DC comes out.
Okay. Basically, alternating current, this is the symbol for alternating current. It's like a wave, a sine wave. I know, I don't draw too well, right? But here it is. And here is what you would see on a circuit. All right? DC, direct current, is what you see on a battery, positive and negative. And this is what you're going to see on a diagram. And you would see it even in items, for household items, when you look at the electrical part about it, which a lot of people just avoid, throw away because they don't know. But now you would know what you're looking at. This is telling you it's AC. You see this, and DC. And you see this battery symbol. DC travels one way. This is back and forth movement. Okay? Now, did anybody have an idea what can really hurt you if you're using, let's say, a 120 volt blow dryer? What can hurt you there? The power, the voltage, the amperage?
The voltage.
Well, police use stun guns. They're up to 30 to 100,000 volts, but it won't kill somebody. So the voltage is not going to be the voltage.
Wouldn't it be the amp?
The amperage is very important. You could have 120 volts, and usually the equipment you're holding is how many amps? First of all, it takes about a 0.3 amps to kill you. Dead, gone. The equipment you're using is basically around 12, 18, as high as 18, 12 to 18 amps.
Look at all their faces like, what?
Now, you've heard of people getting shot. People have gotten shot from this, but how come they weren't killed? Let's look at Ohm's theory, the law here, because to quickly recap this, and I don't want to get too much in this, they're always related. Electricity, or what's called voltage. This is the universal symbol for electromotive force, voltage. Amperage right here is intensity. So you could also do this, okay, and resistance. This means to multiply. If you have 2, you'll get 1. Naturally, the human body, dry, like you are, not sweating, not wet, you have natural resistance of about 100,000 ohms. Okay, let's say you have 120 volt blow dryer. I want to figure out my amperage. Your body has 100,000 ohms. This is the symbol for ohms is the omega sign. So now, if somebody has the iPad, which you do, divide this into that number and let me know what you get. Take 120 divided by 100,000. You're getting involved in math.
How much?
120 divided 1,000.
It's 0.0012.
0,
Amps.
0.0012 amps. This is why people won't get hurt, because of the natural resistance that your body has. Okay? Now let's say you are wet. This number gets cut in half and this number gets bigger. But that does not mean that to do what you want. Always be careful with it. Because you're going to have gels, you're going to be working with gels, which is a liquid that could transfer electrical shock to somebody.